Welcome to another session on managing Microsoft Azure Stack. My name is Mark Grimes, and I'll be presenting this session on control plane monitoring. Once again, I have several handy shortcuts for you to find many of the topics in this presentation. All of them start with the same beginning, aka.ms/Azure Stack, and then we have /monitor, capacity, SCOM, and Nagios. So those are resource links you want to write down and will hopefully help you out for the material that's in this session. Let's look at the agenda we're going to talk about. We'll talk about management and monitoring basics with Azure Stack, about how it works and how it's different compared to traditional management and monitoring over server environments, traditional server environments, Hyper-V, VMware, things like that. We'll look at monitoring Azure Stack from alert remediation, capacity, and Azure Monitor, which is a platform on Azure Stack now as well. And finally, integrating with existing tools. From the shortcuts, you could tell, we have highlighted SCOM, Nagios, and then there's other tools inherent in the system that you can leverage as well. Let's start with the basics of Azure Stack management and monitoring, looking at the Azure Stack components. Azure Stack software components are internally monitored via several resource providers for health services, the Service Fabric Health, and the metrics and logs are centrally collected. And then we have hardware monitoring from the OEMs, which are responsible for agentless hardware device monitoring and validation through external systems. Much of this hardware will be found on what you see in the green box, which is called the HLH, or Hardware Lifecycle Host. So for example, if you have a 4, 8, 12, or 16 node system, there typically will be in almost all vendors except one, which Cisco does not do this, but all the other vendors like Dell and HPE, they will have another server, which is the hardware lifecycle host. And inside that server, it will be running Hyper-V. And in Hyper-V on the hardware lifecycle host, there will be virtual machines, sometimes one, sometimes more than one. And those will be running those services by the vendors like Lenovo and HPE that will do some of that monitoring system. So if you're familiar with those tools, particularly if it's a vendor that you've been used before, you probably know how to use those, and those will live on that hardware lifecycle host. The software storages will be monitored in Azure Stack inside the system. And then we also have REST API for third-party integration of alerts, metrics, and logs. Again, there's a SCOM Azure Stack Management Pack, which you can download. And we'll show you a brief demo of how that works. So if you've used this in the past for things like Active Directory or DHCP, Hyper-V, etc., this is a pretty detailed management pack. And the one thing I like about it, in customers that in particular have multiple stacks, since we currently do not have cross-integration across stacks, in other words, each stack is its own endpoint, and has a different URL, we still can use SCOM to collect that data across multiple stacks to have a central point of monitoring many stacks in one place. So that's pretty cool. For third-party tools, there's also Nagios, and we gave you that shortcut as well, how to access that. Infrastructure Resource Providers Overview. So all these RPs, resource providers, so we have the Fabric Resource Provider, the FRP, the HRP, the Health Resource Provider, and the URP, or the Update Resource Provider. All these resource providers, so at the bottom of the picture, we have a partition request broker that works and gets information as we do or see or get things from the way we access, whether it's the portal or templates or CLI or Visual Studio SDK. Those communicate down through the Azure Resource Manager API level. And then those talk to the broker, which then talk to these other resource providers. And these are just the ones that we're talking to related to health and monitoring. Of course, there are several other resource providers that provide functionality like storage, compute, networking, things like that. Each resource provider has a northbound API, REST API, which is consumed by the UX for all these tools that we have on the front end. And also, each resource provider uses a southbound API to communicate with the controllers, as we described. So here is a nice puzzle piece, a hardware management diagram. So again, starting at the top is where we interface in the portal or through the command line tools. We use the Azure Resource Manager level, and then that communicates to all the resource providers as we just talked about. Then there are other managers for things like physical node management, infrastructure deployment, network controllers, and then those can work with functions that we may do, like, for example, if we need to power on or power off or recycle, change boot order, if we decide to use external radius or LDAP, those are different things we can control. But here's the key point, is that those actions in the gray boxes are triggered by asking the Fabric resource provider to do something. So you tell the Fabric resource provider to do stuff, as we said, in the portal or through the PowerShell or CLI or Visual Studio, whatever. And kind of the key summary point of all this, it's all ARM. It's all Azure Resource Manager. There are various ways under the covers to authenticate and to be authorized to talk to the core components, whether it's LDAP, Radius, baseboard management with saved credentials, or directly to the Fabric virtual machines. And then we have all the external monitoring, which is on the left in the purple, and we'll talk about receiving alerts as well. Now let's talk about monitoring Azure Stack. Here's the problem, that it's the complexity of understanding health. There's a lot of signals being generated, whether it's in Azure or Azure Stack. And there's many different technologies, but the health of the cloud is not the sum of its parts. So how do alerts relate to health? We have to decipher, what do I want to take action on? What do we need to address first? And what are the steps to resolve? So this is a fundamental approach that Azure Stack has taken to simplify this. In a lot of systems, again, we get so many signals. Sometimes you have to figure out ways to sort and filter through all that. Azure Stack fundamentally makes it a bit easier. But if you need to drill down and get to the nitty-gritty details for deep troubleshooting, that is possible as well. But we give you just what you need and just when you need it. So health of the underlying stack is shown through alerts. This is all managed by the HRP, or the health resource provider. And then you consume these alerts to suit your own tools and processes. So you can use some of the tools that we're going to talk about and show, but also if you're clever enough and have the skill sets to make API calls, you can extract a lot of this information out as well. Azure Stack manages and monitors all the software in the box, but the OEM, they will provide management capabilities for the hardware, including their in-box network switches. The HLH, or hardware life cycle host, which we talk about, is OEM specific. And as we mentioned, those tools by those third-party OEMs for that particular hardware will be running in those virtual machines inside Hyper-V on the HLH. So this is a common theme, that Azure Stack is designed to be treated like an appliance. Everything is sealed underneath the hood of the car. So when we see underneath the hood of the car, what we see and get to, we can touch the portal, we can touch the command line, we can touch PowerShell. And then those commands, as we mentioned, go through ARM, and then they go through the controllers, and then they go down into the resource providers. So most of our interaction is driven by alerts. So basically, if it's not broken, don't touch it. But if there is something that we can do and remediate, it will tell us. And if we can't, we have support to help out in that case. But Azure Stack Component Health should be directly tied to alerts. Very simple, red light, green lights, so we can see what's going on. And as we said, philosophically, we want these to be easy to understand and identify very quickly what the next steps are. We can resolve these using common Azure Stack admin action patterns, and they're specific to Azure Stack. So in Azure Stack, the new role compared to any other experience you may have in the cloud, like for example, Microsoft Azure, is in Microsoft Azure, you're not playing Microsoft. You don't have to deal with all the backend stuff. Now, as we just said, in Azure Stack, it's like an appliance, and most of the stuff we don't go under the hood of the car. However, there may be some things that we can do. And so some of these alerts will help us out with that. So particularly in thresholds that have been hit. Maybe we're running out of IP addresses, right? So we get an alert for that. So that's the thing I think that's important being an Azure Stack operator. Again, we manage a stack. We don't really operate it. But in the case of the health, we need to be aware of what actions we can do to rectify any of these alerts when they give you the next steps. So this is a little more detailed diagram. You'll see this in many different presentations at Microsoft Ignite and other places. Again, starting from the top, how we get to things, all the resource providers, from just real quickly, Fabric, Storage, Compute, Network, Health, and Update Resource Provider. That's what we're looking at through the broker. They then talk to the underlying stuff. So from that RP layer down, that's what we call under the hood of the car that we're not getting into. And then there's also Windows Server Health Service alerts for things like the physical desks, the network adapters, and the nodes inside the actual Azure Stack system. And then we can have agentless monitoring of hyperconverged hardware using the BMC or baseboard management controller, which that solution is dependent upon the hardware vendor, and each vendor has their own solution. If you use Dell, HPE, or whatever, Lenovo as examples, you're probably familiar with those tools. They're very common. And then for our network devices, for switches monitored via SNMP, those can be external monitoring solutions that we can collect information from. And then Azure Stack alerts can be consumed by external monitoring solutions as well. So some examples of alert and remediation. An infrastructure role is unresponsive, severity critical, so it tells you what the component is. And here's an example of alert remediation. It actually tells you what to do. Navigate to the compute controller infrastructure role and restart the rule. And there's a link that is provided with that. If the issue persists, because we may have to get under the hood of the car, then you contact support. And one of the best ways to do that is you just go to your Azure portal with an account that's tied and connected to Azure Stack, and then you can enter that information. And we have another session where we walk through that process. Low memory capacity in Azure Stack region. So again, for capacity management, gives a description to add a node to the scale unit using capacity management admin blade. And that process is documented on our Azure Stack operator documentation. Same thing with a physical disk has failed. Tells you it failed. So the process of preparing the virtual disk has been initiated. You have to replace the disk to ensure full capacity. And then there's documentation out there to do that. And in some cases, I've been on customer sites where the diagnostic tools from the vendor recognize this. And they actually shipped out the disk to them, just like happens on servers sometimes. And the disk appears, and they then go to the portal and they see this warning. and they already have the disk in advance. I'm not saying that happens all the time, but sometimes it does. Let's look at Azure Monitor on Azure Stack. Azure Monitor is the platform service that provides a single source for monitoring Azure resources. This is the same thing we do in Azure, and we've brought it to Azure Stack now. With Azure Monitor, you can visualize, query, route, archive, and otherwise take action on the metrics and logs coming from the resources in Azure Stack with experiences consistent with Azure. And then you can work with this data by using Azure Stack Admin Portal and all the other various flavors of access that we've talked about, from PowerShell, CLI, and the REST APIs, which are very powerful. Azure Monitor on Azure Stack provides metrics for the compute and storage services, with additional services to be added in the future. Applications can run in the OS of a VM running with the Microsoft.compute resource provider. So these applications and virtual machines emit their own sets of logs and metrics. And Azure Monitor relies on the Azure Diagnostics extension for either Windows or Linux to collect most application log metrics and logs. And this is a list on the left-hand side of the various types of measures, everything from perf mon counters to event logs, event sources, manifest-based ETWs, crash dumps, and customer error logs. We can use these things for monitoring data. So some monitoring data is already stored and available in Azure Monitor for a set amount of time, which they're stored for 90 days, the metrics are. Activity log entries stored for 90 days. Diagnostic logs are not stored. And the archive, we can archive the data to a storage account for longer retention, something that we're working on at Microsoft. Query, you can use the Azure Monitor REST API, again, CLI, PowerShell, .NET SDKs, those things that we talked about, to access the data in the system or put that in Azure storage as well. And for visualization, there's some of these that are in the portal for monitoring data and graphics and charts. And one thing that's really cool is you can, on the main page of your portal, just like we can do in Azure, you can make custom dashboards. If you do a search on making a custom dashboard in Azure, it works the same as an Azure Stack. So if you're drilling down through an interface, like for example, you go down through region management and we go to network, and then we see some statistics on network, or we see some statistics on storage and capacity, and we see a nice little chart. You can right click on that in the upper right hand corner. There'll be a little pin icon, and you can pin that to your default dashboard. So what I've done before is you go to the top of your default dashboard in the Azure Stack operator and you say new dashboard. I call it Marks Monitoring Dashboard. And once that's that's being displayed at the front when you log in, then I can pin these other pre-built little charts and graphics that are all over there. As we mentioned, all this stuff is also accessible through APIs. So you can actually route this data to Microsoft Power BI or whatever visualization tool you like that can use REST API calls. It takes a little bit of trick to figure it out, but once you get that connection using the authentication token and getting that running, then you can kind of play with and learn how to slice and dice that information. As an example of things to see, if you do a search for GitHub CCO dashboard, we have made this public for Azure. So it's a great dashboard, does some KPI metrics on various things, and you can take a look at what that looks like and what are the possibilities that you could do in Azure Stack as well. And then finally, as we mentioned, you can route this data to third-party visualization tools, either live streaming or have the tool read from an archive in Azure storage. And all these methods, again, we've talked about for accessing monitor data. Not all methods are available for all actions, but they all have their various strengths. So Azure Stack Portal, again, it's going to be, it's going to give you what it's going to give you, right? And we're more likely going to get the more detailed information using things like PowerShell or CLI or the REST API, where we can query and drill down deeper beyond what the default portal options are going to show you. Let's talk about how the health resource provider actually works. So the HRP, I think we've said it before, the health resource provider. It provides and allows actions on Azure Stack alerts. It's the provider that collects and displays metric data, and it runs as a service fabric in the XRP VM. Why would you care about that name? Sometimes that may pop up in some of the windows. So if it says you got to restart the XRP VM, that would tell you. And if you don't know how to do that, that would provide information to the support call. The HRP provides a list of resource providers and the infrastructure roles to the portal UI that allows an administrator to assess the health of Azure Stack elements. So this is a deep diagram. It almost looks like an electrical diagram, but this is kind of the internal stuff, right? This is more just kind of FYI. I'm not going to test you on it. Won't be any quiz, but it breaks down how all these various components work. So in the center here, we start with the health provider health storage account, which is on the stamp. And then that does HTTPS calls to the health and monitoring, which has a Windows Universal telemetry client. And then that can send information through the Azimuth, which is off the stamp. So we have all this data that's being collected and provided. And that can go through to Microsoft through telemetry interface, right? And then later on, we can analyze that to understand stamp behavior. That telemetry setting can be disabled. But we do upload all alerts so that we have a better understanding of how things are working and how we can improve. Finally, on step number 4, there's a response to external component calls for alert lists and details, the region health, and the list of registered resource providers and resources. Registration with monitoring. All foundational resource providers are registered with the health resource provider during deployment or redeployment during patch and update. So what we mean by the foundational resource providers is what we've talked about in other sessions. The vendor comes in, they do the hardware check, they build Azure Stack, and we have by default compute, storage, network, key vault, resource providers. And those are foundational resource providers. You didn't have to do anything. It just came with the system. However, value-added resource providers, so these are the things an Azure Stack operator would add after the deployment by the OEM. Things like app services, SQL, MySQL, do not currently register with the health resource provider, but that's the intention for future enhancement. Each registration provides the display name, the storage account dedicated to monitoring, and the alert templates. Delete what I'm going to say here because my first statement, I believe, was incorrect, that I should not say app services. So I'm going to start over again on this slide. All foundational resource providers are registered with the health resource provider during deployment or redeployment during patch and update. So what we mean by foundational resource providers, these are the compute, storage, network, and key vault that out of the box just are there after the OEM sets this all up for us. But some of the value-added resource providers like SQL and MySQL do not currently register with the health resource provider, but that is the intention for future enhancement. Each registration provides the RP display name, the storage account dedicated to monitoring, and alert templates. Infrastructure resources are also registered and linked to the resource provider. The registration data is used to determine which resource providers are healthy and which require attention. And then alert templates determine which actions and which alerts will be shown to the user. So therefore, each resource provider defines its own alerts and declares them to the health resource provider. Let's talk about alert remediation for Azure Stack infrastructure. So these are the key actions. The core principle is that administrative actions are driven by alerts. So the resource action hierarchy is how actions are applied when recovering functionality. So some of the available actions for the infrastructure role instance are start, shut down, and restart. And for the scale unit node, which that's your individual servers in an Azure Stack integrated system. So if we have a 4-node system, we have 4 scale units. We can repair, drain, resume, shut down, or power on or power off that scale unit node. Some of these scenarios may require accessing the privileged endpoint and documentation on accessing that privileged endpoint, or PEP, can be found at aka.ms/Azure Stack/PEP. As an example, we have an infrastructure role that's just unresponsive, and we got to get it running again. It needs to be restored. So again, the available actions: start, shut down, restart. But restart is implemented as a logic that orchestrates shut down, turn off VM, and start VM. So it takes care of all those things. And again, we have the fabric resource provider, works through the compute controller, and then performs these actions on Hyper-V. So again, another example here, a scale unit node is not responsive and its functionality needs to be restored. So some of the actions are drain, resume, or power on, off. All starts with the fabric resource provider, talking to the compute controller. And then in the case of a drain, resume, it works with failover clustering. In power on, power off, it works with the enterprise cloud engine, and then works with IPMI, which is the Intelligent Platform Management Interface. And that is a set of computer interface specifications for autonomous computer subsystem that provides us management and monitoring capabilities independent of the host system, CPU, firmware, etc. And so that communicates, the ECE through IPMI communicates with the BMC, there's a lot of acronyms, the baseboard management controller. Here's another scenario. So we have a repair action, which is split into 2 operations behind the scenes in the ECE. The first action is to provision from bare metal and adding the machine into the cluster. Once that is done, the controller will check if the data disks do contain data. If yes, it will not touch the data. If the disks do not contain data, they are wiped and added to the spaces pool. FRU, or field replacement unit. Again, this process and how to do this is well documented in our documentation. But so you get an alert, and the scale unit does not respond because of a damaged motherboard. I actually had this happen one time at a customer. And just like in the hardware for the hard disk scenario I talked about before, that was indicated by the vendor and the motherboard showed up. So we had the light up in the boards from the alert, and it also arrived based on the manufacturer's indicators letting us know that happened. So we get an alert, we enable maintenance mode to drain it, and then we can turn off and then turn on, and we have the ability to use the KBM viewer with that. So when we turn on, we check to see if the alert was resolved. And then with the OEM help, they come there and they replace the part for us. Then we enable repair mode and then disable the maintenance mode, which then resumes the system. So what happens if you can't use the actions? But you can't get to the portal. The portal's down. The directory service or storage are offline. What do? So on the service provider machine, we can use PowerShell only, get to that PEP or privileged endpoint, and then from that, we can open up a ticket and we can use the GMSA, the Globally Managed Service Account, domain admin account, with the help of the support to get into those infrastructure role instances. Okay. So as a service provider in the lower left-hand corner, you see here's the process. We can create diagnostic package. We start the unlock process. We talk about this in another session, which is kind of like it's like the two keys, the submarine. You got a key, and then Microsoft support has a key. So you send a key, they send you a key back. That unlocks the hood of the car. You can get in underneath there only through the direction of the support. But all hands on keyboard are by you, unless you really want to give it up and let them do remote control. But generally, they will direct you. And I've been in calls where they were just copying and pasting. They copy the commands, and then I run them on the stack. So that drives all input. And then the Microsoft support, they will receive that diagnostic package and the logs, whatever they determine they want to get from you. We go through this authentication, the screen sharing we said, and then they guide you to perform these actions. Capacity management. So on the right-hand side, here are some of those nice little KPI metrics I was talking about. In this case, looking under capacity. So if I right-clicked on each of those, I could say pin this to my dashboard, and then when I click in the upper left-hand corner where it says Microsoft Azure Stack Administration, if I had that new dashboard called Mark Monitor, it would pin those on there, and then I could go somewhere else and pin some more, like for example, my IP addresses if I wanted to. So these are the simple ways that we can view these metrics and add these into a custom dashboard. And if we want to get more advanced, we could use API calls. And again, as a reminder, check out CCO dashboard in GitHub, and you can see an example of how we've made this available to the public to do these sorts of dashboards for Azure. So that source code is all open. We don't have that open now for Azure Stack, but it's the very similar process. IP pools. So example, I'm running out of IP space for my external VIPs. In scenarios where I've been with CSPs that have multiple Azure stacks, this is one of those things that we kind of figured out. Oh, the first time we did it, we ran out really quickly because we just didn't have a good expectation or understanding of what was needed. So when we deploy the next one, we were able to expand that range so we'd have more IP addresses. But we can always add more after the fact. Now, very important caveat about this. We know you'll be very careful when you add IP pools. But if let's just say as an example, if you decided to add an IP pool and then later on someone says, you know, I really need that somewhere else. Can we take that away? And the answer is no. So there are some decisions that if you have to revert those, it actually becomes a redeployment. So just be really careful when you select those IP pools to add in. Another lesson learned I had on this is interesting too. So I had an environment where in their Azure Stack, they wanted to have 3 different networks in their subscription for the users. And with each network, they wanted the addresses to dynamically apply different IP pools based upon 3 different ranges that were added after the fact. You can't do that. It's going to go through the pool kind of like filling up the bucket. So you can't expect in a dynamic IP address scenario that it's going to pick those IP addresses from different ranges. So again, decision like that is a bad decision because it would have to be a redeploy. So just be careful about playing your IP pools. figure it out in advance, be a little progressive in making a wide enough range to think about future case scenarios. And then if you do, again, just be careful when you add additional IP ranges. Okay, and these examples here are obviously with PowerShell, how we can add this through there. Here's a decision conversation connecting outside of Azure Stack. So do we want to use the portal only? Or do we want to connect to external monitoring capacity or ticketing systems? So how do we do that? How are we going to make that connection? So the principles are this, and this is the magic. So as I mentioned, there's a CCO dashboard out there. If you're going to do this same sort of thing and make these custom Power BI dashboards, you have to authenticate with Azure Active Directory and get a token for the admin subscription. And then you call the API namespace with the correct action to get to this. So all the details for the REST API is in the documentation at the bottom. So it's the REST API for Azure Stack. So just walks through the tool. We get authenticate with Azure Active Directory. We get the token, goes through ARM, and then which communicates through the resource providers and to the health control, and then sends that information back, which would help to provide the graphical display that you want to have. Okay. So these are all documented. Just going to go through these rather quickly here, but some of the actions that we can do in this case for the Fabric resource provider. So you got gets, puts, and posts for all these different namespace resources for location or region, infrastructure roles, logical network, storage subsystem, file shares, role instances, and scale units. Health resource provider API resources. Again, location alert, service health registrations, resource health registration. And there's an example here at the bottom of how to query an Azure Stack region of a subscription for current alert properties. So you see the very in the bottom, they have these color coded, which is nice. So the alert properties are the last line in purple. So we have the alert ID, the state, title, resource name, created timestamp, and remediation. The update resource provider, again, get and put for the resources of location, region update status, and the update runs. So now let's look at monitoring and integrating with the bigger picture Azure Stack related systems in your data center. We can do ITSM integration or IT service management. So we can use this by adopting existing pipes. We can monitor with existing data center monitoring tooling or use existing connections from monitoring to ticketing and others. So within the integrated system, at the top box, the big box, we have our Azure Stack Software, we have our physical server, and we have our network devices. We said network devices communicate through SNMP, going to use third-party tools for that. The physical servers, those are communicated to by the BMC, the baseboard management controller, which could be specific to the vendor. And in all the Azure Stack software, everything we've been talking to up to this point, they're well-defined REST APIs. We went through some of those and the various actions that could be performed. All that information can talk to the monitoring solution, which can then talk to the ticketing or the CMDB database. So monitoring integration solutions, as we mentioned, from our shortcuts, the ones that we use and love, of course, is Operations Manager, because that's our baby. That's what we do. And we have a very nice comprehensive management pack. We'll give you a little demo on that. For the physical server and the BMC, again, Systems Center Operations Manager, SCOM. The management pack can do some of that. Also, we can use the Nagios plugins. We gave the shortcut for that. OEM supported monitoring solutions. And then there for network devices, there's a Nagios switch plugin. And by the way, on the aka.ms/Azure Stack/Nagios, it talks about all these various different plugins that you can use. And also for the tenant subscription health monitoring, you can leverage the SCOM Azure Management Pack as well. So let's take a look at this demonstration here of walking through. So let's look at where we're starting here on the left-hand side. When you look at these folders, you see Microsoft Azure Stack, and we're starting with the Health Dashboard. And the deployments, there are 4 different stamps. So we're looking at Shanghai, Redmond, Seattle, and Orlando. And we have Seattle selected with 1 region. Of course, right now we can only do 1 region per stack. So that's what it is. So let's take a look at what this demonstration will show in here. So what we're going to do is drill down into various areas. So as we click in each one, there's the Shanghai, and we see we have 3 active alerts. And we look at the Redmond, and in that we look at the Redmond region, nothing going on there. Same thing with Seattle. Okay. So again, we're going through multiple Azure Stack instances. And here we do a force update run refresh. It says the update had failed, and we can restart an update run as well. So those actions are on the run task on the right. So now we take a look at the update status dashboard. Again, browsing through the 4 deployments and looking at the Redmond one. And there is an update. We see we have 1 update for the hotfix. 1805, it's an old one. And then we can just simply say apply update package or force update refresh. Then we can go to the infrastructure role dashboard. And again, there's our 4 deployments. And look at all the roles. We can see as we click through those that here's the compute controller. And that tells us there's those XRP machines we talked about. And we can force a refresh, restart, shut down, start infrastructure role, or stop it. And again, we can navigate through Redmond and look at Azure Resource Manager user and the roles that are used and force a role refresh. We can look at the scale unit dashboard. So here we're going to Shanghai, and there is the cluster. And there are the 8 nodes for that cluster. We can drain, we can force a refresh, we can power off, power on, resume, and shut down that scale unit. So lots of detailed information drilling down across multiple scale units and the nodes within the scale units. Hardware monitoring and ITSM integration. So Azure Stack will natively surface alerts for physical disks, JBODs, and node failures. All other hardware monitoring will be provided by the OEMs, as we mentioned, or by using external monitoring tools like SCOM or Nagios. We talked about the networking, the physical server, and how it's all implemented in the HLH or hardware lifecycle host. And enable ITSM by using existing pipes. Again, we've got the SCOM, the Nagios, the Azure Management Pack for Azure Stack Tenant subscription that we can do, and API documentation, which is very thorough. And for additional information, we have monitoring and updating examples in the Azure Stack tools, which we're assuming you have installed already in your admin workstation. But in the GitHub repository, it talks more about that. And there's also a master list of Azure Stack commands as well. Let's look at health resource provider troubleshooting. So a couple common issues. Health HRP service can't access health storage accounts. Data not flowing to storage accounts from nodes, VMs. The services are offline. So if we cannot access storage account, the impact is it's not going to be able to create new alerts or get telemetry or update metrics for the specific RP resource. Data is not going to get pruned, and the issue can occur when storage is down globally or when storage keys were rotated and monitoring system was not updated. So administrators will be presented with alerts around storage not available. It's a good thing. And there may be some already closed alerts right at setup time. This is a result of some extra early health assessments while Azure Stack goes the first time setup. So a potential resolution for this would be, if storage is available for everyone else, you can try to rotate the storage keys. If the storage is offline, look for other alerts related to storage. If data is not flowing to storage accounts, the impact is going to be data collected on the host doesn't leave the OS instance. And when enough time passes, the local data will start being overwritten and cause potential loss in monitoring data. For alerts, the monitoring service will notice missing data and display missing host or VM alerts and possible resolutions. This could be caused by an issue in storage or networking, so look for alerts in those areas to understand what the heck is going on. Here's the crying cloud. You ever seen this? So this happens sometimes. So if the UX doesn't display a list of RPs or roles, this could be happening. List of regions and region health cannot be retrieved. Or the SCOM and Nagios integration is broken. So the potential resolution for this is to restore the health service fabric applications. But to do that, you're getting under the hood of the car. So that's going to be a support call to get the required access, and they'll walk you through that. So again, support will guide you through all that to get to the PEP. We talked about how to get there, the shortcut aka.ms/azurestack/PEP. And then you will use the PowerShell commandlets. You'll be guided by the support to restart the health applications. You can use the Fabric Resource Provider API to restart health role. And if health service in either resource provider or Azure Stack Health is offline, the application will appear offline. All the components of monitoring follow the same diagnostic pattern as the rest of Azure Stack. So we have various event provider names from Azure Stack Health to the Web API to the common infrastructure, HTTP, and you can use common practices. You can use common practices developed across the components to get further details from the data log. There you have it, folks. That is our session on Azure Stack control. There you have it, folks. That is our session on Azure Stack control plane monitoring. Hope you found this information useful, and you may be able to leverage the resources and links provided to you throughout this presentation. I'm Mark from Microsoft. Thank you, and have a great day.